So that design practices need to be followed in each and every construction practice for the infrastructure. It should not be only for buildings, but it should also be for the bridges or pipelines or transmission line towers or whatever you are doing. So that was missing earlier, but nowadays the trend has changed. So these characteristics are also now built into the infrastructure design practices. Cyclone, you can see the second figure of our country. Like we have marked it, how many states are getting affected by cyclones and its severity. So the structures which are existing in those states need to be built for the cyclone resistance. Is there any provision today we are taking for that? No. Only for some specialized structures, we used to consult certain organizers and get things done for this cyclonic resistance. But all the buildings, whether it is a single story or double story, also need to be seen through this angle, whether it can withstand the cyclonic event. Landslides, I think you know, in Kerala, most of the in some places these landslides are also a common problem. So the structures which are being constructed should be at some distance, or how to protect those structures. That also, I don't think there is some guideline as of today. That is also taken up in a case-to-case manner. So that also needs some trends which should be there in the at least in the future as well. Coming to the man-made hazards, it's blast. It can be due to gas cylinder burst, or it can be due to the burst of crackers, or it can be due to a terrorist attack. So our structure, which is constructed using conventional materials in a conventional manner, whether it is capable of withstanding those kind of extreme man-made events. So that also is an area where you can think what can be done for that. And also you can see in India, these many states which are in the third figure, it's not given here. So another thing is the climatic resilience. So when we talk about climatic resilience, it's about coastal, thermal and flood related. So coastal, as I was mentioning earlier, because of the rise in the sea level and also the change in the tidal pattern, the salt inundation is the major problem. It is happening to the walls, it is happening to the floors, it is affecting the overall health and well-being. It is affecting the, it is affecting the people who are living there are not able to do their day-to-day activities or job. So we need to see what can be done to improve the coastal climatic resilience through the construction practices, so that overall well-being can be improved. So as of today, I don't think there is any solution. It is also taken up in a case-specific manner. And flood, like a sudden spell of rain, the total city or total stretch gets flooded. So what have we taken steps for that? Some places we have seen stormwater drains being implemented. That is the only thing what we are seeing today. But there are floodgates, flood barriers, and many other options which is adopted in the abroad countries. So we also need to see whether those kind of practices can be brought into our country for the better flood resilience aspect. And thermal, I'm sure I don't have to explain much. What the maximum temperature we used to feel 5 or 10 years ago, what we are feeling now is totally different. So our buildings, there should be some methodology to prevent the thermal conductivity, or we should use some materials which have better, lesser thermal conductivity compared to what is being practiced, so that the thermal transmission can be reduced to inside the building, and we can feel comfortable at least when we are inside the building without the use of air conditioning and so on. So that aspect also need to be thought about, addressed and brought into design practices. And also one such option can be whenever we are doing a retrofit, like if it is a structure which is already existing and we are doing a retrofit or rehabilitation for the structure, that retrofitting strategy can be integrated with the thermal strengthening strategy. That is one of the trend which is seen nowadays. So at one go we can get two benefits. like if you consolidated way, if you see what is resilience, it is about prevention, it is about adaptability, and it is about mitigation and reduction. So these are the 3 points which we should be aware whenever we are doing a design, and see whether we are satisfying these 3 criteria with respect to the infrastructure component or the system what we have developed. Now going into the details of it, when we talk about resilience for earthquakes, okay, so choose ductile materials compared to brittle material, which will give more energy absorption to the overall system. So that is one way to bring in resilience for earthquakes in a building. And there is a trend of using dampers which can absorb the shock or vibration during such events. And also there are some damping devices which are kept in between the floors or columns and beams, which also reduce the shock due to earthquakes. And in some structures we use bracings, and that also will lead to collapse prevention in case of earthquakes. So these are some of the emerging trends which we are practicing to bring in resilience for the earthquakes if the structure is already built. Now cyclone. This cyclone aspect, if you can have a shape, you can bring in cyclonic resilience by developing different shapes. So this is one such example where SCRC has come up with cyclone shelters, and it is deployed in Orissa, and I think 23 of the such shelters were built along the coast of Odisha. And whenever some cyclonic prediction happens, people used to shift to this kind of shelters. But the point is, why we have to wait that long to shift the people? Why can't we build this kind of structures for the residences or the buildings which is existing in such kind of cyclonic regions? So that also need to be emerged. Next. Flooding, as I mentioned, the stormwater drain. But here good point is, I think till last year, we used to have only this cast-in-place construction practices for the stormwater drain construction. But recently, there is a lot of adaptation of the precast U drains, which as stormwater drain. And I think in Tamil Nadu, I think they have done a lot of coverage for the stormwater drain using this precast system in the last 2 years in the Jal Jeevan mission. And in many areas, this has found to be very effective. So it is also a matter to be checked whether our roads have this stormwater drain passing along, so that flooding will not happen for rains which is happening for the small spells or so. So, but in 2020, I think only 25%, I'm not sure of the year, 25% of the road network were only having the stormwater drains. And due to this Jal Jeevan mission, this number has increased. But all across India, if you see whichever state is getting affected by the flooding, the stormwater drains need to be installed in a larger manner to tackle this kind of flooding. Floodgates and flood barriers are not seen anywhere in India today. But in abroad countries, whenever there is a prediction for the flood and all, they used to just open it up, close it using the floodgates, so that at least some of the houses get protected from the flood events. So that also need to be adopted and to be thought about for the new innovative techniques. Coastal climatic resilience, I'm sure you may be knowing that India has around 7,500 kilometers of coastal line, and 3.5% of the population is residing within 50 kilometers of the coast. So there is a domino effect which is being experienced by the coastal communities, that is spring tide coupled with ever increasing sea level. And you can see in the picture, it's a picture from Ernakulam district itself. So the salt water is surging inside the homes in coastal area, and every year they have to do some repair for this walls, floors and all. So what is the solution? Till now it is not addressed, that is I have been told recently, and we are coming up with new methodologies to address this kind of problems. And also in these communities are using only mud bunds, mud bunds, and that are not effective during this kind of water inundation. So also we need to see how to prevent erosion, as well as how to prevent the water entering inside beyond a particular level. So those needs different level of techniques so that this community's overall well-being can be improved. So one of the option is saline resistant construction, but you may be knowing about waterproofing, but there is no waterproofing which has saline resistance. So it is not about the chemical, but it is the opportunity for us to come up with new saline resistant concrete in a cost effective manner for this kind of construction for this coastal communities. Thermal climatic resilience, we need to adopt new building materials which has different rate of heat conductance, because if you see the heat, temperature range across various states in India, you can see a difference also. So you can choose the construction materials in different manner, which has different rate of heat conductance, and also there are possibilities to build building envelopes and attach to the existing structure or to the new construction, which will lead to thermal resistance. That is also being done in some of the places, and that also is an emerging trend which we are seeing today, and hope it will pick up in a greater manner. And also we can look into the paths which can generally transfer this thermal energy, mainly this foundation walls, joists and connectors, and bring in innovative methodologies there which will address the thermal resistance. And appropriate, we are very much aware of the dimensions of the brick, but it's not only the brick, but there can be other materials also. We can select the selection area, thickness, thermal, and materials which has the thermal conductivity to tackle that particular specific heat also. And smart materials use and phase change materials use are being seen to provide thermal resistance to many construction methodologies nowadays, but that needs adaptation in our country. But those are some of the emerging trends which you can see in a global context. Facade design, like building envelope, yes, that has emerged in India. In Mumbai and Mumbai and Hyderabad, lot of buildings are there with lot of building envelopes and facades, which can be used to build in thermal resistance to the buildings. Blast, there are many, like as I mentioned, there are many types of blast. Some trends or some materials which you can use in this context is SIFCON, slurry infiltrated concrete, which has higher impact and blast resistance, and laced steel concrete composites are also there, which research has proven that it has improved blast resistance because of the more ductility and all. And foam core integration is also seen in literature, and it is claimed that they can also lead to better blast resistance. Next. Okay, so that was some of the emerging trends. Now coming to the material, like which I was mentioning, textile reinforced concrete. Let us see how this material can be, we can call it as a material for the sustainable and resilient infrastructure construction. So I'm sure most of you, this material will be new. So to give a brief understanding, it consists of a non-metallic textile. Let me tell you, it is not ferrocement. Don't get confused with ferrocement. It uses non-metallic textile and a cementitious binder. And this non-metallic textile can be glass textile, carbon textile, PBO, aramid, and so on. And the cementitious binder is not cement sand aggregate, but it has cement, mineral admixtures, only fine aggregates, water, and chemical admixture. Here we are not using any coarse aggregate. Since it is non-metallic, we don't have to provide that minimum cover requirement of 25 millimeter. Because of that aspect, we can build up the thin elements of particular target strength and ductility requirements for the many applications. So, and also in the right hand side, you can see different type of textiles, like it is called woven textile, knitted textile, bonded textile, and so on. there are both two-dimensional as well as three-dimensional textiles available. In India, we are yet to use three-dimensional textiles, but two-dimensional textiles have already come in certain applications that has mass application in this context. So to give just an understanding about the performance of this material, so when we talk about RCC, all of us know that this Fe415 or Fe250, how is the stress strain characteristics. But when you talk about textile reinforced concrete, it is not about the stress strain behavior of textile, but it is about the stress strain behavior of the TRC composite as a whole. So there are RILEM and ACI guidelines which are used today to characterize this TRC and see how the stress strain characteristics are. And from that characteristics, we can derive the design parameters. That is how the design of TRC is done as of today. And you can see 3 stages of stress strain characteristics in this kind of material: uncracked state, multiple crack formation state, and stabilized state. And if you want to have a conservative design, you have the flexibility and freedom to choose what is the straining value where you have to stop the, where you have to do the design. So whether you want to do a conservative design or non-conservative design, you need to get this stress strain characteristic and decide accordingly. And also, if you can keep on increasing the number of textile layers up to some optimal number, so that you get more tensile strength. So you can see with 3 layers of textile, you are able to achieve tensile strength of around 12 MPa. With 6 layers, you can achieve around 22 MPa. I'm sure all of you may be aware that concrete is having tensile strength in the range of around 2 to 3 MPa. So TRC, you can achieve up to 20-25 MPa using glass textile and around 30-35 MPa using carbon textile. Now under flexure, this is how it behaves. You can, if you subject this TRC under flexure, this particular panel keeps on bending without breaking. So you, there are many multiple cracks you can get when this kind of panels are subjected to flexure. And on the right hand side, you can see how the flexure behavior of the TRC is. As you increase the volume fraction or the number of layers, that dip, what you are getting after the first crack formation will reduce, and it will lead to a bilinear behavior at the end. So that is how we have to design depending upon what is the flexural strength you are targeting for a particular design of such components. So here main thing what you have to note is it's the number of layers or the volume fraction, and also how you are positioning the textile in a particular cross section. So that also matters. So, but you have a lot of flexibility to see how to do this design. Under impact loading, if it is a concrete, the first figure you can see it just breaks into parts. If it is a reinforced concrete with steel reinforcement, you get scabbing. If it is a fiber reinforced concrete, you can see the crack pattern which is spread across the length and width of the specimen. But if it is a textile reinforced concrete, you get a very localized impression. So suppose you have a full facade system with TRC panels, and something gets affected due to impact also, locally you can remove that particular panel and replace it. So that is the kind of advantage this material has compared to other conventional materials that are being practiced. Now, in nutshell, what you can say is that we have n number of possibility to choose the textile or the binder ingredient, and also we can bring in alternate binders for the TRC, and also do the optimization for a standalone application, or you can also integrate TRC with other materials for to create another products. So high cost or low cost practices can be brought in based on the situation, how the situation matters. And because of this customization possibility of TRC, we could come up with a new production technology for we have got a patent also granted. So it's called textile reinforced concrete prototyping. So it is a technology to produce various shapes of TRC products for various structural and non-structural applications. So like when we started developing in the year 2014, so at that time we used to tell like it's a single technology for creating multiple products like multivitamin tablet what we used to take. So because one technology you get multiple products. So if you see, look at the picture in the left side, the binder, you can see how the mix is getting mixed up. And if you need to add some pigments into it, you want the panels to be colored, you can add the pigments into this binder mixing itself. And also you have the flexibility to place the textile layer or feed the textile as you are seeing in the fourth figure. And also you have a uniform placement of the binder and textile. And in the wet state of this production process, you can cut the sheet like we used to cut this halwa or Mysore pak and so on. So the same consistency you can feel when you produce this kind of TRC sheets, and that sheet can be placed over, whether you want a curved surface or a corrugated surface, the rectangular sheet you can place over that particular shape, and the next day you can just take out your TRC product. So it is a single technology wherein you design and built in the design characteristics in a rectangular sheet, and use and which will lead to the use of different geometrical shapes for different applications later on by just putting it into that particular shape. So in a rectangular you build in the design, you get whatever shape you want. So that was the claim for which we got a patent. And like as I told, this was like you can just add the pigments, no need to paint it. So you can see different panels being used for this. Door panel was around 10 millimeter thickness, and the plinth slab 18 mm, and the roofing panel was around 12 mm. So all these were produced using TRCPT technology. And when we started this research, that was the stage when the Swachh Bharat mission was in first phase of Swachh Bharat mission was going on. So we could build an easy to build texture reinforced concrete toilet in which only 2 people are needed to lift the panels. There is no need of any cranes or bigger machineries. And this concrete post is having a groove, and you can easily insert the TRC panel into it. And also you don't any machineries, and this can be done by any location and any place. So this demo toilet of TRC has 10 TRC panels, and including the plinth slab, door slab, roofing, etc. And that has been that know-how has been transferred to industry, and they have upscaled into various types of structures. And in the COVID context also, these TRC toilets were implemented in a makeshift hospital in Arakkonam, and you can see the attached toilet and bathroom in this second figure. Now using the same technology, you can also produce TRC liners, which can be used for various applications like canal lining, water pond lining, and wastewater pond lining. So again here you need to produce that TRC sheet, and that need to be brought into the site, and whether it is already damaged canal or structure, there also you can have this liner, and also you can have the liner with the greater thickness if it is a new construction. Tiles is yet another application. So here point is heavy duty tiles can be produced using TRC of a thickness in the range of 15 millimeter itself, and which has a lot of because the current practice is to have bigger tiles for heavy duty application. So if it is a warehouse or so and some tile get damaged, you have to replace the full part of it. So this kind of area, if you have a smaller dimension, that is better opted one in such situations. Also, non-load bearing panel, you can integrate this kind of TRC panels with EPS like expanded polystyrene or calcium silicate or gypsum, which gives thermal resistance also to the overall system. So this TRC is a well adapted material with other materials with either as a whole or by combining with shear keys and so on. So I just wanted to show you the various possibilities which are emerging, but and also you can think how it can be taken forward in a bigger manner. Load bearing, like TRC as alone is not load bearing if it is a 15 mm or so, and if you are using glass textile. But if you are using carbon textile, yes, you can call it as load bearing. So with glass textile, what you can do is you can always combine it with other materials. So in order to have a 100 ton capacity wall panel system, Here you can see this TRC skins are integrated with profile steels with embossments, and self-tapping screws were used to connect those two. And we developed a spacer system to connect the two sets of panels, and put together the system could carry a load of more than 100 ton. So it's also a material which can be combined with other materials for improving the strength, bringing into a load-bearing panel. So there are many application areas, like you can use it as infill, you can use it for many industrial buildings or multi-story building or external facades. But the main advantage is easy erection at site, because the weight is less compared to what we used conventionally. It is less skill intensive. Anybody can manufacture it, less labor intensive, and fast track construction practices and so on. So some of the structures you can see here. Next one. Yeah, this is industry, yet another industry upscaling of what we have developed. This wood, like whatever interior design we used to have for our homes and all, now especially if you look at the kitchen area, I think more than 6 years you have to do some repair for that kind of area where the water is falling. So in that earlier days we used to have concrete slabs, but with this TRC you can see it's 12 millimeter thick slabs. So now one company is also doing TRC decor of the interior design with TRC modules and slabs for the overall building. And also it is being used for building construction, wherein you can see a figure wherein this TRC panels are brought into the site, and it can be just implemented, and it can lead to faster construction of the single story buildings. So multi-story buildings research has to be done. But we are very glad that this, I think this was done by one MSME industry in Rajapalayam, where they have tried out our TRC liner technology for this house construction. The previous one, click on that video please. Okay, next slide. Okay. So yet another application is as boundary walls. So you can see it's like, again it is like a concrete post with grooves, and you can easily embed the panel into it. Here generally for the precast, for the boundary walls, we used to use pre-stressed concrete panels or precast concrete panels. But here for the same length or same specification, because of the thin nature, it may not be suitable. So what we have done is we have made two flaps of the single panel. So because of that flap alone, bending moment demand reduced to 1/3. So you have the flexibility to have different shapes, which leads to better benefit in very particular applications like this boundary walls. So this technology has been transferred to L&T, and they have done a trial stretch in Delhi-Mumbai Expressway. And also recently they have completed a trial stretch in Tiruvallur railway station using this textile reinforced concrete panels. Yet another application is clash barrier systems. So in Indian context, if you see in the city roads or you can see the median barriers which are being built in cast in place manner. And also when a vehicle comes and collides against it, the vehicle gets seriously damaged, and the passengers also get injured. So when we characterize this texture reinforced concrete, we could see that this is a material which can absorb more energy compared to conventional steel reinforced concrete. So we thought, why don't we try out to develop this kind of crash barrier system, which may suit as median barriers. Towards that, it's a precast system. So we have done, but in Indian code, there is no test methodology described for the crash test of this kind of barriers, because we are used to only reinforced concrete barriers. But there is an IRC code which tells that, next slide please. So these are the IRC code requirement which tells that it should have a particular design moment resistance in these areas. So we tried to build in that kind of moment of resistance into the configuration, and this product development was qualified for low containment crash barrier applications. So for this also we got a patent granted. Now we are just waiting for a real crash test to happen on this particular development so that it can be put into practice. Next slide. Coming to repair, retrofitting and rehabilitation, it's a well-known material abroad for strengthening of masonry and concrete structures. It's mainly because of the substrate compatibility of textile reinforced concrete, because you don't need any additional anchors or additional screws to fit this textile reinforced concrete to the existing structure. So you can see if you have a plate of TRC, you can just paste it into the existing wall. That will increase the shear demand of the panel system. So it is a best suited material to impart earthquake resistance for the existing structures. Also, you can impart enhancement in strength in the plastering thickness. So instead of the normal plaster, if you have a TRC like cast in place strengthening methodology, you can have the panel strengthened using this material. So if you do this laminate bonding methodology, we could see that there is 50% of optimization of the TRC material compared to that cast in place method, which is shown in the left side. And there is the 24 to 30% increment, and we can design based upon what is the enhancement requirement for this kind of situations. And also there is a comparison between how this precast bonding and cast in place methodology works for this kind of applications. This is yet another application for which also we have a patent, how to strengthen an existing concrete beam and masonry wall in a plastering thickness. There are certain characteristics of the textile through which we can improve the efficiency of the textile layer when we do the strengthening as shown in this figure. Next slide. Also, we can bond the TRC cast in place layers into the existing beam, or you can also bond it with epoxy. That will lead to enhancement in the strength and ductility characteristics of the reinforced concrete beam, which is already in place, and it is a material which can be opted for strengthening of RC structures. Coming to structural cum thermal retrofit, it is a recent study wherein we have just worked out whether TRC alone or TRC integrated with the calcium silicate or EPS can lead to structural cum thermal retrofit possibilities. And also we tried out whether this conceptual strategy will work for clay brick wall, hollow blocks and AAC blocks. And also we just targeted a particular enhancement in the shear demand and a particular enhancement in the thermal characteristics, and which system should be used. We derived a methodology. That method was proven to be successful, and this is a proof of concepts which tells you that it is a material which can be thought about for this structural cum thermal retrofit. I know you are not able to see it clearly, but here my point is, if you have a particular requirement of some percentage enhancement in the strength and you have a percentage requirement in the thermal performance, you can choose the materials and you can design the materials accordingly, and we can get the targeted performance. And also which will perform better was also being studied using finite element analysis and also using the analytical methodology. And this material and its combination with EPS and calcium silicate was proven to be suitable for clay brick wall, AAC and hollow blocks. Yet another application which we completed recently in Pune as decentralized wastewater treatment plant unit. This was an Indo-German collaborative project. So our industry partner implemented it in a Pune site. At SCRC we have done full finite element analysis, prototype development and the full-scale testing for its qualification for use as decentralized WTP plant. And both circular and rectangular tanks which you are seeing here are made of textile reinforced concrete. And on the right hand side you can see how factory has implemented it, and you can see the connecting pipes wherein we have just pierced, we drilled some hole for this connection. And this kind of decentralized systems are very much needed in the rural and semi-urban areas for treatment of wastewater units. So this project we recently completed, and now we are doing stormwater U-drain using textile reinforced concrete. for L&T is our industry partner, and that we will be completing in the coming July. And also I would like to say that this waste fishing net, that is also being tried out as reinforcement in textile reinforced concrete, because ocean pollution is also a matter of concern. Though it is not given a lot of importance now, but in coming 5 or 10 years you can see that matter also will be taken up. So we thought while developing this kind of products like U-drain and all, hybridization of the waste net by some modification method, that also the research related to that also led to very promising results. So that is also ongoing in our institute. So I think these are the developments what we have done with the textile reinforced concrete. So thank you all for your kind attention, and any clarification specifically related to TRC I would like to address. Ferrocement is chicken mesh, steel mesh. TRC is non-metallic textile. Reinforcement binder, the stress strain characteristics. TRC is better because if you see the micro cracks that I have shown in the uniaxial tension and flexure, it is very hairline with multiple cracking. So that hairline crack width you cannot get in ferrocement. And you can bring down the crack width by staggering the textile positioning and all. So you can choose the textile mesh size. If you are going to construct a very durable structure, you can have lesser mesh size. So whatever cracks will happen only in that particular mesh opening area, but it will be having lesser crack width compared to a mesh which is having a larger opening. Water binder ratio. So here mostly we have done with 0.4 water binder ratio, but super plasticizer is there. COP will be around 10 to 15% in most of the cases. So whenever we do the characterization, we should have at least 5 number of samples. Yeah, because coating we did manually. So if it was done at a factory, COV will reduce, because manual coating has always. Yeah, durability studies were done on this. No, waste fishing net we did additional coating using some material, and that we hybridized with glass textile. So fishing net alone will not qualify for the structural purpose, but when you hybridize it with glass textile, that becomes a new textile system. So that is taking load. We can increase, because the stormwater drain, we have two configuration, 500 by 500 U shape, and another one is 800 by 800. There the thickness is 80 millimeter, because it has to qualify for HMV application. Binder thickness you can increase, because if you like beyond 4 layer, there will be delamination, but you can bundle it. 4 layer, again some binder, again 4 layer, like that you can bundle it. Binder, same binder will penetrate into the mesh sizes. Yeah. If it is for a canal lining, or if it is for a building construction, if you have canal lining purpose, you can have the cost ranging from 350 rupees per meter square to 650 per meter square. But if it is a U-drain, you will have around 800 to 1000 rupees per meter square. That depends upon what is the application and what is your design. Boundary wall, what I have been told by the industry was they could get 60% cost effectiveness by using TRC compared to pre-stressed concrete walls. So, so it's not there. Now BIS has come up with a working group to come up with the guidelines for use of TRC recently. I think 2 months back. Wall 20 mm panels. Railway used 40 mm panels, but Delhi Mumbai Expressway it was 20 mm. FRP you have to use polymers. Here it is. FRP is polymers. Here it is cementitious system. So FRP is always over predicted, because if you want only 20% increment, your FRP sheet will give you 40 or 50%. But with TRC, if you want 20, you can design 20. Calcium silicate, gypsum and EPS. These are the three what we have tried out. Yes. Yes. I think for coastal resistance in Germany, they have considered aluminum panels along with TRC sheets. It is like adaptive, what is it? Adaptive envelope or something they are calling it. Mm to 15 mm. Reducing the, yeah. Because that much is enough to function for that particular requirement. So it can be fitted as a facade. Yeah, that connecting mechanism and all. I think it's like a normal facade design and implementation, but that panel will be of this material. So that other methodology can be the same as what you used for with other materials. Because you can screw it, you can drill it, doesn't matter. Emerging students, some questions? If it is masonry structures, as I told you, remove the plaster and use this TRC. If it is panel, you can screw it. Addition screw also we can provide. Yes. Or if it is, because its substrate compatibility is very good, you can just have it pasted also. On top of plaster also you can do it. For that reinforced concrete beam, we just pasted it. But if you need additional anchorage, you can delamination of the concrete to TRC is not happening. But in the TRC, between the textile layers and binder can happen if the number of layer is more than 4 in particular case. Because if a binder is having a bond strength of around above 2.4 MPa, it will not debond from the concrete. So if your binder is having that much bond strength, the chances are less to debond. No problem. Additional safety. Yeah. ACI, one recommendation is there, which will tell how many number of layers you have to put if you know the design characteristics, design parameters of that textile and TRC. Yeah. Overlay. If you want to increase the shear strength, you have to calculate what is the shear strength requirement and how many number of layers and what thickness can provide that number. So if it is bending moment, again you have to calculate that way. So it is number of layers and the thickness. Full thing is there. Yeah. That is what somebody was asking, na? That E value is like for concrete and TRC, it is like in the range of 25 to 28. Whereas for FRP, it is around 70. So you are attaching something of 70 GPa to 20 GPa. Yes, I know. Yeah. That won't come here because it has similar stiffness. Yeah. Yeah, that is also one point. Good. Yes, yes. I understand. Correct. Yes, yes. So when they told like TRC can be used like this, first question was, what will happen if somebody sits on it? Because if you see some 15 nobody psychologically accepts it. So this industry used to show this video to wherever he go for this kind of promotion, like nothing is happening. And also we had another photo wherein a lot of TRC panels were transported in a, like petty auto, we tell here. Na? So it was like bumpy road and it was just moving around, and when it reached the site, nothing happened. So that workers in that site were very happy, saying that, sir, nothing happened. We were thinking it will break. So that and all you will see only if you see. Termite resistance, like wood and all, termite attacks are more, yeah, common. So in this, and also I think maybe if you wait 2 more months, they will bring matte finish into this kind of decor. So they have some plan to match it to the aesthetics of the wood using this TRs. Archana blocks in Rajapalaya. So we transferred this basic know-how, but they made TRC decor as one of their product. Yes, yes. Yeah, yeah. Model, yeah. Yeah, sure. Not aerated, yeah. But I think also Mobasher has done some work on aerocone panels along aerated concrete along with TRC for some impact resistant panels also. I think there is a research team going on Arizona University. Yeah. Yes, yes. But only one institute is doing, so you have to see what are the results. No.
So thank you, ma'am. As you started talking about the strength, durability, sustainability, and about the resilience, and how to incorporate risk, that is bringing out more sustainable structure, and about the infrastructure that is existing and the new structures. And you also pointed about some emerging trends such as the ingredient material composite design practice, health monitoring, and about the surface life extends. And also you pointed out the 3 criteria, that is prevention, adaptability, and reduction in resilience. And you also introduced us to the textile reinforcement concrete, how to customize it, and various applications. So we are very grateful for you to come over here and taking off you from your busy schedule and to attend the workshop. So thank you, ma'am, for coming, and it was great innovative talk, ma'am. Thank you. Now I request everyone to come forward for a photo session. And also please join at 2 p.m. for that next technical session. Thank you all.